Okay, so how do we expand logarithmic expressions? It really kind of comes in like 2 or 3 steps. So you're going to have one logarithm, and it's going to have some base, whatever the base is. And then you're going to have stuff in here. There might be multiplication, there might be division, there might be exponents, but you're going to have some stuff in there. First, split the multiplication and the division. Now, if you're going to do it the long way, I would do the division first and then the multiplication. So in this instance, I would say log base b, b squared. Oh, no. Sorry. I did that wrong, didn't I? And I just got done saying it matters what order we put this in. Okay, log base b, you'll have to put ax. Now I meant to talk about this when we had this before, but you do, I think I might have mentioned it, you do have to have those parentheses because the argument is ax. It's both of them, okay? And then you're going to have minus because it's division here that we're splitting up. Log base b of b squared. Okay. Then, that's the division. Then split up the multiplication here. So you're going to have log base b of a plus log base b of x minus log base b of b squared. Now, that splits it up into individual logarithms except for the exponents. So the exponents you have to deal with. Normally we bring them down in front, but the exponent here is 1, the exponent here is 1, and we have a property for that one. So remember that property I keep talking about, property 3? So we'll keep using it. This is just going to equal that exponent too. So I'm going to simplify this. Oops. So number 2, take care of exponents. I should say bring down exponents. Take care of exponents. And then step 3 is to simplify. Now, we know that, let me finish writing this, log base b of a plus log base b of x, and then minus, we know it's 2, but let's say you forgot that property and you're like, oh, it's an exponent, I want to bring it down in front. Okay, 2 log base b of b, which a lot of times that's what you have to do. But this is property 2, right? That just equals 1. So anyway, we knew it was going to be a 2, but log base b of a plus log base b, that was supposed to be a b, it almost looked like a 10, huh? Of x minus 2. So the last part you're going to simplify. So pretty much you're doing the multiplication and division. You can do them both at once. I didn't this time. I just did the division, then I did the multiplication. Then you have to take care of the exponents. A lot of times you're just going to bring them down in front, but if you can simplify, you'll simplify as well. Okay, so we have 2 examples here. I'll do A. All right, so here's the argument that we're taking the log of. You can see the multiplication, hopefully, right there. So it's log base b of x squared plus log base b of the square root of y. Okay, I'm going to run out of room here, but that's okay. Now, I can bring the 2 down, and that splits up the addition. There's no division here. I can bring down the 2. And so 2 log base b of x plus, now I have to remember that this is log base b of y to the 1/2. So remember, anytime you see a radical, you're going to change it to exponential form so that you can bring down that exponent. So I'm going to have 2 log base b of x plus 1/2 log base b of y. I look at them to see if there's any simplifying, like is anything 1 or 0? Nope, this is done. Okay, so that was A. Now we'll look at this one, B. It's a little more complicated. So I have B, and I have a numerator and I have a denominator. Okay, so I am going to do it in 2 parts. I'm going to split up the division. So it's log, now that's a 6. I'm going to try not to make it look like a B. And I have the cubed root of x. Now I know I'm going to have to deal with that, but I'll deal with it later. Minus log base 6. And then this is the whole thing, the whole denominator. So I put it in parentheses because I need them, and I have to make sure that I'm taking the logarithm of all the denominator. Okay, so here we go. Let's write log base 6 x to the 1/3. Okay, so we're going to change that radical to a rational exponent. And then minus, now I'm going to bring in a parenthesis here, log base 6 of 36 plus, so I see this multiplication here, 36 times y to the 4th. I have to split that up. All right, log base 6 y to the 4th. Okay. And then I'm going to have to distribute that minus sign at some point. So let's just do that now. Log base 6 of x to the 1/3 minus log base 6 of 36, which I'm going to deal with that, minus log base 6 of y to the 4th, and then we'll deal with these exponents. So, how many steps you write kind of depends on how much you want to do at one time. I could have split those up and said, oh, they're both in the denominator, so I'll be subtracting both of those. Sometimes I do that if I'm like in a hurry, but this is a little bit safer route. We don't always see everything. So anyway, all right. We almost have all the exponents, but I'm going to do one more thing before I bring those exponents down. You could bring them down now, but I'm going to do it all at once. That 36 is 6 squared. Now, how do you know to do that? You're going to have to say, hey, could something happen here? Or, is there a relationship between 6 and 36? And there is. So I want to write that as 6 squared minus log base 6 of y to the 4th. Okay, now I'm going to take care of the exponents. And a lot of times I do just draw the little dotted line to say, hey, that's coming down in front. So 1/3 log base 6 of x minus, okay, now that's the property we've been working on, property 3, that just equals 2. Minus, and then I'm going to bring down the 4 log base 6 of y. And that's expanding it, it's making it bigger. That's how you do it. And we've simplified already, so, all right.